Good evening, everybody. I'm using this. Yeah, so those of us who work with the impact craters, it feels a little weird that, impact melt, which is produced during the cratering process, uh, we see impact melt deposit, but we are not able to see the crater which formed it. And that is part of the curiosity that we are pursuing. In this presentation, I will be talking about the morphological investigations. So what makes the impact melt deposit anomalous? For those of you who may not be working with impact craters, here is an example from crater Tycho, where the black splotches are the distribution of impact melt deposits. And as you can see that the impact melt deposits are kind of distributed around the crater, both outside and inside. In contrast, we have this particular deposit, which was first reported by Mark Robinson and his team. And here, the distribution of these impact melt deposit is quite weird in the sense that we are not able to figure out where the source crater is. So how this deposit looks like, one thing is that on a regular, say, VAC image at 100 meters, it can be very difficult for you, but even at NAC resolution, you may have to really stretch your imagination to really look for these small, subtle ponds, which have a very smooth morphology and occur in all types of depressions, most of the time, sometimes also draping the surface. So I'm talking about these impact melt deposits, which are distributed across a very large area. This is another kind of depiction from Robinson's work. So based on the previous work, the understanding is that this deposit extends over 7,700 kilometers square. Another paper actually reports twice of that. It is primarily kind of morphologically defined as very smooth, has a very young crater age, which is in line with the morphological freshness of these deposits. And multiple possibilities have been explored, including fluidized basin ejecta, pyroclastic volcanism, effusive volcanism. We heard about pyroclastic volcanism in a talk earlier. And finally, impact melt. The authors favor the impact melt origin for this deposit. And the potential source craters have been based on the estimates of impact melt that was produced or that was estimated based on the mapping, the crater count age and the geographic location. Because these deposits are very young, so the associated crater should be also very young. Another interesting aspect of this is that these deposits are located at the antipode of Tycho crater. And so there has been a proposal that these deposits represent melt that was transported from Tycho all the way to its backside of the moon and deposited there. So in terms of why it is relevant and what questions remain to be answered, as I said in the beginning, to have an impact melt deposit and not having a associated crater is something very fundamental, especially for a planetary body like the moon, where the moon is dotted with craters, right? There are abundant craters, and still we have this impact melt deposit, which we are not able to tag to a particular impact crater. So it has direct implications for understanding the cratering process, specifically the emplacement dynamics of impact melt. I think a lot of answers are hidden in the spatial distribution of impact melt deposits and the trends. Another aspect is what is their composition. If impact melt is produced at one crater, then the same melt composition should be present at another location where that impact melt has been deposited. This arrow points to the antipode location, and you can see that the deposits are kind of huddled around that. So the question is Tycho as unique source of impact melt deposit, or there are other things that we need to consider, given the fact that this would involve transportation of material in excess of 5,000 kilometers. So what we have been doing is we have been looking at this deposit from a variety of angles. We have been using data from multiple missions and at multiple spatial resolution, including imaging data from LRO WAC, Selene, and LRO NAC, spanning spatial resolution from 100 meters to 1 meter per pixel. We have used topographic data from LOLA and TC merge topography, and spectral data from Chandrayaan-1 MQ. So what we did was we used this initial marked up deposit area and expanded it into different sectors and analyzed it in detail. So the first result that we found was that in contrast to what was already mapped and reported, we found a lot more area based on the image survey, which is almost 1.5 times. And this survey is based on the detailed evaluation of more than 400 NAC images. So those of you who have worked with NAC know how difficult it is to work with so many images. So I won't say that this work is final yet. And so there is the spatial extent that I have mentioned here is our current estimate, and it may expand. So earlier on, I mentioned that the estimate of impact melt volume has been used to identify the source craters. So once the areal extent of the impact melt that is mapped exceeds, so your impact melt volume is also going to exceed, which means you need to find another set of craters which can match that criteria. So it has direct implications for that. So stay tuned for more information on this. Just to kind of share the newly identified impact melt deposit, these look similar to what have been reported earlier with the subtle morphological expressions and diversity of forms, including ponds, flows, and veneer. So although they are tiny, but you can see how fresh they are. Again, those of us who do morphological studies, we know that this kind of crumpled texture will go away very fast. So these has to be really, really young. And here is another kind of deposit. And you can see the contrast between the margins where inside it is smooth and outside it is rough. We also used topographic studies, and we found that the distribution of these impact melt deposits, they are somewhat correlated with a high-rise platform. So in this black box is the region where the smooth melt deposits occur, and the red regions, which are the higher regions here at high elevation, a lot of impact melt deposits are actually occurring over there. So the question is that was there a potential topographic barrier when the melt was being transported and being deposited? So did a topographic barrier stop the transportation of impact melt? So this is also something that we are further investigating to find out if there is an elevation threshold with respect to the melt pond distribution. One potential issue with this is that these ponds are so small, and to find out this elevation threshold at a much coarser resolution, that becomes a challenge. So once we have this information available, that will provide additional constraints for the melt and placement models. And finally, we studied the ejecta ray distribution patterns of 9 craters that were proposed as potential source craters for this impact melt deposit. And what we did was we compared the derived impactor direction based on the ejecta ray pattern and compared it with the location of smooth melt deposits. So for example, here we have the crater Jackson, where the yellow indicates the direction of the impactor, while the location of the smooth melt deposit in the opposite direction. Here, the assumption is that the impact melt should be concentrated in the downrange direction. So essentially, favorable craters will be the one where the downrange direction coincides with the smooth melt deposit locations. So with this, we have been able to actually rule out 5 craters out of 9, and 4 craters are still remaining for further investigation. There is some uncertainty in inferring impactor direction using only the ray pattern. So additional evaluation is underway. Here I would remind that the enhanced melt volume that we have found from morphological studies in our spatial survey will bring in new craters, which will have to be studied for their ray patterns. So from our study, there have been emerging trends in terms of extended spatial extent than the previously mapped effort. It will enable tighter constraints on the impact melt deposit geometry, how the melt deposit is occurring. And the preliminary evidence indicates topographic control during emplacement. And from ejecta ray pattern, we have ruled out certain craters. And I would end by saying that these smooth impact melt deposits hold important keys for understanding the emplacement of impact melt during the cratering process. Thank you.